All right, so today we're going to talk about the rain shadow effect. We're also going to talk about mountains. We're also going to talk about temperature and whatnot. Now, mountains, this mountain peak here is actually, assume this is a mountain. Look at the shape of it. It has an elevated peak. Air masses will be forced to rise up and also descend. Now, the prevailing winds will be associated with the side where they have the oceans and where the winds are in fact coming from. If the air masses will be forced to rise up, given the shape of this slope, the air masses would rise up and obviously condensation would occur. That is the cooling effect involved in the hydrological cycle. Now, this condensation would occur because of the moisture-laden or moisture-rich air, which moves further and consistently upon the land. It will be forced to condense, which will produce cloud cover. Cloud cover marks the start of condensation. Well, I should say condensation marks the start of cloud formation. My bad. And obviously, why would you get much more rain at the top of the mountain? Because the cloud cover will be much more pronounced there, where the air will become very much saturated until the clouds can no longer hold anymore. All right. Now, students, this being said, the windward side of the island, which is on this side, I'm showing you here, which is the area where the prevailing winds are coming from, that windward side of the island will receive a lot more rain. Why would it receive a lot more rain? Is because of the fact that you have that you have that amount of moisture coming from the sea, moisture rich saturated air, and of course they are forced to uplift and condense, and this rain will fall and it will basically be able to feed the vegetative cover and influence the vegetative cover on that part of the island. That is the reason why the windward part of the island is said to be associated with a lot more vegetation and vegetative cover than the leeward part of the island, which is on this side. The leeward part of the island is in fact the area which experiences the dry descent of cool, unsaturated air. All right, as you can see, it is called the rain shadow area. Why? Because the rainfall is less concentrated. As a matter of fact, there is little to even no rain. All right, so students, just keep this in consideration because the windward side receives a lot more rain, whereas the leeward side receives a lot less rain, if any. The windward side of the island, especially at the upper slopes, the rain will be much more concentrated in the upper slopes rather than the lower areas. This is one of the reasons why all rivers originate at the top of the mountains because rain is actually much more concentrated at the top of the mountain and slope. And that will actually cause the fluvial movement of fresh water to be channeled in streams and whatnot, creating the start of rivers, which will eventually, under the influence of gravity, will descend further down out towards the sea. So it's a very cyclic process. So just to reiterate very quickly, the leeward side, which is on this side, which is the right hand side of this particular mountain, experiences descending unsaturated dry air, whereas the windward side experiences a lot of rainfall, dense cloud cover, prevailing winds. All right, moisture and saturation is pronounced here. The upper part of the mountain is in fact associated with a lot of rainfall, primarily because you have that point at the highest peak where the cloud density is at highest, and also you also have that amount of rainfall receipt there, primarily because of the prevailing winds consistently feeding moisture upslope. All right. Um, why is it that temperature is actually cooler at the top of mountains? Because the higher you go, right, above sea level, doesn't matter which direction, but above sea level, right, you realize that temperature will become cooler because temperature cools at an average rate of 6.4 or 6.5 degrees Celsius for every kilometer, or 6.4 or 6.5 degrees Celsius for every 1,000 meter, which is the same thing as saying 0.64 or 0.65 degrees Celsius for every 100 meter into the atmosphere. All right, that's the reason why mountainous regions are cooler. So class, I hope this was basically helpful. I just want to show you one little example here with respect to the rain shadow effect. All right, taking in consideration that we're talking about a continental landmass here. I'm going to show you South America now. All right, so students, here we are looking at South America here. We can see Brazil, Venezuela, Colombia, and whatever, right? Now, this little section, oh, my bad, hold on. Right. So we know fully well prevailing winds actually come from the right-hand side of the actual landmass. All right, from this side, prevailing winds actually come there, South America obviously experiences the southeast trade winds and also by some extension the northeast trade winds, depending upon where you are, either above the equator or below the equator. Below the equator will be bombarded more by southeast trade winds, whereas above the equator will be bombarded by more of the northeast trade winds. And look at this class. Moisture or warmth from the Atlantic Ocean is blown inland, all right, and that actually results in the condensation and by extension precipitation to be a lot more pronounced in this region of South America. All right, this green area is in fact the Amazon region, the Amazon rainforest. It's called a rainforest for a reason because it experiences a lot of rainfall primarily because of the amount of uh, rain it receives. All right, no rocket science behind that, right? Now, pay attention to this here. With respect to the actual area, this brown section, now there's the Andes Mountains is a full mountain chain which exists in South America around this region here. And what happened is that that mountain is elevated. Take about the same principle I showed you all. The winds are prevailing. The prevailing winds come from this side. And eventually the Andes Mountains, which are very tall mountains, they will eventually rise up and eventually deflect on this internal area here. All right, the air masses and the rainfall will be a lot more concentrated on the interior. All right, because the mountain region is here. So this region here is experiencing the windward part, all right, or the abundance of rainfall. Whereas on the outskirts of the Andes, which is on the further west of the Andes mountain chain, the peak, we have a desert-like condition experienced in this region here. This is what you call the Atacama Desert, and is actually on the leeward side of the South American continent. Why? Because it is not bombarded by significant trade winds per se. All right. The dominant trade winds are in fact concentrated in the outer eastern part of the continent. And as a result of that, the leeward side of the island always experiences a lot less rainfall in comparison to the windward. So as you can see, this little brown section is in fact a desert, whereas you can see a huge disparity on the other side of the mountain, which is on this side, where you're seeing green, is dark green, that is actually the rainforest. All right, you probably wonder like this area is up and this area is further down south, but class, bear in mind the earth is slightly tilted, right? All right, the earth is slightly tilted a little bit. All right, so I hope that was actually able to help you with respect to understanding this particular note per se. And any questions you have, feel free to let me know. There's not a problem at all. All right, students, you'll keep safe and revise for tests. I'll see you all. Bye bye.